hurricane wind power, and today I want to talk with you a little bit about wind turbine ratings and the relationship between blade diameter and power output. So today I just want to share with you a video that I'm going to be sharing with my customers in relation to power output, understanding blade diameter and the relationship to power output in wind turbine ratings. So I'm going to start out and I'm going to share some things with you, some resources on the internet, which I will put backlinks to in the video description. I encourage you to, if you're thinking about buying a small wind turbine, or if you want to look at advertising, some of these resources are available. So I just want to direct our customers to secondary resources that are reputable and promote a better understanding. So over the past 10 years, a lot has been done, and frankly on my YouTube channel, we have done a lot with focusing on generators and generator outputs and driving things with drills. And basically, a lot of people are overlooking what the generator is. The generator, or permanent magnet alternator, is it's a tool. It converts mechanical energy put from a blade set or rotor into a generator, and it converts it into electrical output. So to do that, you have to have RPM, and you have to have, most importantly, torque. And if you cannot produce torque, you might not get the output that you're looking for. There's been a lot of stuff, and I get 5 to 25 of these emails today. I'm going to share one with you, and I want to explain, what we're doing here as a company and, the direction that we're going in. We want to help out everybody, but in some circumstances, I can't provide technical support on other people's products. From a business perspective, from a liability perspective, if I tell you to do something that you bought from another company, you may void your warranty, and we would just recommend that you get in touch with whoever you bought your wind turbine from to get technical support from them. But here's just an instance. It says, I bought a wind turbine from, I'll redact this. It says, after receiving it, I found out it doesn't come with a pole and a mounting bracket. The bottom of the wind turbine has a round plate, has 4 holes drilled in it. I need something that will bolt up to the plate on one side, and the bottom side should fit a vertical pipe. Can you help me out with this problem? Name redacted. And again, we would love to help out everybody, but we're here to support what we sell and define what we sell. And if you have something that's not working and you need to replace it, give us a call. Otherwise, I'm going to, if you have output questions, I'm probably going to refer you to this video. So hopefully you can understand better wind turbine blades. So I'm going to go through some of these resources. I'm not going to edit this video. If I misspeak, feel free to correct me in the comments section if you disagree. And I apologize in advance if this isn't the most organized presentation, but this is to help you understand the relationship between blade diameter and output of a wind turbine, okay? With regard to wind turbine output power, there are 2 standards that a lot of people don't understand. The first thing is continuous output. And for the purposes of my video, I'm just going to define this as, if your wind turbine is in a straight orientation and it had a steady straight line wind at a specific given mile per hour, how much power would it put out continuously? If you have power that goes up and it goes down, we have to convert this in kilowatt hours, and that's your power production over a period of time. So if you have a few hundred watts coming in and you get excited about that spike, you're probably not going to be producing the kilowatt hours that you want and may find out that you're disappointed. Some of you on YouTube have had arguments over this stuff and are seeking the truth, and I guess everybody has their own form of truth. Everybody has their truth. Today I'm here to present you some facts, and we will backlink in the description below to where you can read these things for yourself. So how you rate a wind turbine is not something that is, there are industry standards, and I'm going to read off some of these to you. After I finished explaining, we talked about the continuous output parameter. The other output parameter is instantaneous output. And that's the power flash that I was talking about that you might see until your wind turbine catches up, the load on the resistance catches up, and then the blades aren't able to continue the rotation. You see that flash for a moment, and then your power is back down to a much smaller amount in many cases. So, let's start off with actually just, there is science involved in this stuff, and what I have is the formula for the output of power in the wind. So in this formula behind us, P equals power, CP equals maximum coefficient. This is 0.25 to 0.45. This relates to efficiency of your wind turbine machine. A common efficiency rating is 0.25 to 0.30, and the theoretical maximum, known as Bett's limit, is 0.59. I will put a link in the video to where you can look that up, but for the sake of using these calculators that I'm going to backlink, go ahead and factor in 0.25 to 0.30. Give people the benefit of the doubt and put 3.0 when you're, if you're questioning something. P equals air density cubed. A equals the rotor swept area. So this is the rotor swept area, or diameter, is the part that I think a lot of people are overlooking. And we got a big blade back here on our 2 kW wind turbine, and I'm going to get that out for comparison in a little bit. But if you don't have that rotor diameter and the torque input, you're not going to get the electrical output. V equals wind speed, and K equals constant yield of power in kilowatts. That's our continuous power output rating. So what standard or how many miles per hour should we be looking at when we rate these things? And I got a couple. I think this is from Wind Power Monthly. I don't have this marked, but I'm going to just read from a couple things. This article says most U.S. manufacturers rate their wind turbines by the amount of power they can safely produce at a particular wind speed, usually chosen between 24 miles per hour and 36 miles per hour. And it goes on to give the formula. The National Research Energy Laboratory and the Small Wind Energy Council certifies wind turbines. This process is expensive. It costs $50,000 to $100,000 if you don't get a grant. And just for a sidebar piece of information, a lot of you that are looking for the tax credits, you may find out that if you don't buy something that is rated from a Small Wind Energy Council, you may not get that 30%, but you need to check that state by state and with your accountant, and we're not going to start giving that advice. But so what's the difference between the AWEA rated power and nominal power? Where nominal power here, I assume they're talking about the instantaneous power we were talking about earlier. It goes on to say, turbine models certified to the American Wind Energy Standard are required to publish the rating with wind turbine power at 11 meters per second, or 24.9 miles per hour. And this is the power rating which we have been observing in our advertising for the last several years. Goes on to say nominal power designating for marketing purposes. On the next page over here, one of the FAQs, it says, what are the benefits to the certification? And it says certification labels ease consumer comparison with the wide variety of turbine products on the market. Funding agencies and utilities gain greater confidence that distributed wind turbines installed with public assistance have been tested for safety function, performance, durability, and meet requirements for consistent standards. Certification, and let me emphasize this, can help prevent unethical marketing and false claims, thereby ensuring consumer protection and industry credibility. So with that, they have a list of small wind turbines that are on the list, and I will put the backlink to this below. But for the purposes of my discussion today, I've picked out a couple here, the Skystream 3.7 and the Pico wind turbine. And I want to talk about what they were certified at and what the blade diameter is. So the Pico Energy wind turbine, the wind turbine diameter of that is 3.7 meters. I think that's around 12 feet and some change. Don't have the calculator in front of me, but we'll figure that out. This wind turbine it's got a rated 2,420 kilowatt hours per year, but the rated power on this wind turbine is 1.5 kW, so 1,500 watts continuous. And that Peak Energy wind turbine, I may have misspoke a few minutes ago, that's a 3 meter blade diameter. So we're talking about around 10 feet. The next one on the list is the Skystream. It's rated at 2.1 kilowatts, 2,100 watts, and that's the one that has the blade diameter of 3.7 meters, or around, I think, about 12 feet. So, what we've been selling, our rotor diameter on our Hurricane, our big 2 kW wind turbine, is 3.2 meters. And I'm 6'4", so I'm gonna go get this blade and just pick this guy up. And there's 3 of these blades that are used to make this power. So I'm 6'4", and I mean, you see the size of this blade. This is the blade that goes on our Vector 1 kW wind turbine, and there's 5 of these. So if you get a relationship here, you know, you got 3 of these, you got 5 of these. This makes 1 kW. This is what it makes to make 2,000 watts. And if you look at the blade diameter compared to the wind turbines that have been certified, you're going to find that these blade diameters, when you start putting them into some calculators, are consistent with what the rated output should be. So, I'm not going to say anything on the phone that I wouldn't look at the camera and say myself, but over the past little while, I've got emails, you know, eBay stuff, Amazon, Alibaba, whatever, wherever people have bought stuff, and they have wind turbines with blades that range from 24 to 36 inch blade diameters, and wind turbines that are rated anywhere from 800 to 2,500 watts, and they wonder why they don't get that much power out of their wind turbine and are seeking assistance. And for that, we can't help you because there's science involved. You either have the torque input to make the power or you don't. There's wind turbine charge control systems. They are important, don't get me wrong here. Some of these more efficient axial generators bring some efficiency gains to the table. I'm not discounting that, but you cannot get magic out of by hooking up a specific controller to a wind turbine. For the sake of comparison, I just threw a couple numbers in here for different blade diameters. And I'm thinking, on this one, I stuck 55 inches, that's 1.3 meters. And for the sake of giving the machine the benefit of the doubt, we put 30% efficiency in there at 11 meters per second. And the rated output for that is 400, and I believe that's 33 watts to 453 watts. That's your continuous power output rating on that. The second one I have here, we did it, I think about 72-inch blade diameter. I just stuck this in the calculator. That's 1.10 meters, the swept area of that is calculated in, and that comes in at the same percentage of efficiency at around 807 watts. So what I'm trying to summarize and help my viewers understand in the most educational way possible without being condescending to everybody or anyone else, these wind turbines that we're talking about are not from one company or one person, and we're not beating up on anybody else. I just want to define the relationship between blade diameter and power input and torque. And from a very common perspective, if you have ever had a rusted bolt on a project that you were working with, and you put a pipe over that and extend the arm for leverage, you understand the relationship between power output and torque from a longer lever of a bigger blade to produce power. So we've got a whole bunch of control systems on the table that I'm going to talk about in the next video and what we recommend. And in the meantime, if you are buying hurricane wind power products, this is the practices that we go by. This is what we recommend for people when they comparison shop. If you have any questions about power output, I'm probably going to send you a link to this video. So as to not to get into boundaries with other people. So now that we have that out of the way, what we have for sale here, and I'm going to put a backlink for these, is our Hurricane Big Ass 1 kW turbine. This is the blade from the 2 kW wind turbine that I just showed you. That wind turbine weighs 200 pounds. Also look at the weight. Our XP weighs almost 60 pounds. Our Vector is a big heavy 60-pound piece. So long tubular construction, well-built stuff that will be around for a long time. We have replacement parts for things, so it's not like you're buying something and you'll never see the person again, because we have this stuff in stock, ready to ship. Hurricane Vector, Hurricane XP, Hurricane Big Ass Wind Turbine Series. I have the stuff for the Air Boss. Those wind turbines will be coming out this spring, and we'll be showing you some videos with the coil winding and stuff with that in a little bit. I hope this has clarified the relationship between blade diameter, torque input, and power output. And I own my role for being focused on the generator. Understand, there's nothing about a shiny generator, or if we paint it red, or, there's nothing about the generator that is going to be special if you do not have the rotor diameter and the torque to get the power out. For now, this is Tony at Hurricane Wind Power signing off, and I hope we have cleared up some of these points. If you like our video, please subscribe to our YouTube channel and click on the links below to see the resources that we've shared with you today. Thank you.